Hello! If you want to know how to create this Trippy solver effect in Houdini, keep watching. Let's go! I will create some geometry to work with. So drop down the geo node and give it a name. Then we are going to create a font node. Type in some letters and pick your favorite font. I want the A to sit flat on the ground, so put down a transform node and rotate the A by minus 90 degrees on the x-axis. To create some screen filling geometry, I will use a grid and set the size to be 16 by 9 and the divisions to be 2 by 2. Let me create a transform node. And then we can adjust the grid size so it fits nicely around our letter. Okay, perfect. Create a Voronoi node. Now we can uncheck those groups, we don't need them. And since it's a flat geometry, we need no interior surface and no interior normals. Now you can connect the first input to our grid and the second one to the letter A. Add some nice spacing between the shapes by increasing the cut plane offset. By creating a polyexpand 2D, I can add more points to our fracture to get more interesting shapes. Now I want to create a random attribute per point to be able to colorize the pieces individually. So we create an attribute randomize and set its name to rand and the dimensions to 1. And now we can check copy cell point attributes and transfer the attribute rand to the primitives. We can visualize the attribute here. Next, we want to introduce evenly spaced points to our shapes. To create them, drop down the resample node and adjust its length. Now what is missing is the p-scale attribute. Drop down the vellum configure grains node and check show all points to see the p-scale values. Now we need to adjust the value in a way that the points use the available space while not intersecting with each other. Great, now we got all the ingredients for the simulation. So you can create a pop network, but before we dive inside, let me turn off the grid and tidy up the nodes a bit by selecting them and pressing Shift L. And jump in the pop network. There we can delete the merge node, we don't need it. And on the pop source, let's adjust the emission type to all geometry. And if you rewind the timeline, you see your shapes being emitted to the simulation. Turn off the guide geometry and in the birth tab, in the impulse activation, type $SF equals 1, which means only emit in the first simulation frame. So no matter when the simulation starts, the first frame you're gonna emit the shapes and then stop it. Make it move by creating a pop force. Connect it and set the amplitude to 1 and the pulse length to 10. If we hit play now, we see it's moving already. Create a SOP solver, which is a micro solver that allows you to create SOP nodes. Drop down the transform node and scale it on the y-axis to be flat. Next, we want to dynamically add subdivisions or new points as the shape grow. So we create a resample node again. And for the resample length, we are going back to our other previous resample node and copy the parameter and paste it as a relative reference to our SOP solver. If we hit play now, we see it's flat on the ground and the resolution gets added dynamically. What is missing now is interaction between those points. And we can introduce that by creating a pop grains node wired in between. And if we check that now, we should see some kind of interaction happening. The issue here are missing substeps. We need to increase the substeps on the pop solver, so put it to 10 by 10. And if we hit play now, it should look much better. Now the shape keeps growing and we get this kind of reaction diffusion look, which is not what we want in this case. And to fix that, on the Vellum configure grains node, reduce the p-scale radius in order to reduce the interaction or intersections between the points, and the result will be a smoother, more force-driven simulation, which is what we want for our Trippy solver effect. Now we can start fine-tuning our effect. So I will increase the turbulence to 5 and maybe add a little more detail or smaller details by decreasing the swirl size. Yes, I think that looks quite nice. Okay, let's proceed and cache this out. We're going to jump up and I'm going to visualize the color. Here we go. Now we can disable the visualizers for the p-scale. So uncheck show all points. Now let's clean up the simulation. So we remove all unnecessary groups and attributes. So let's create an attribute delete. And we are going to select the attributes we want to keep, which is the velocity and the rand attribute, and delete non-selected. Let's create a group delete and put an asterisk in there to just wipe all the groups we don't need. Adjust the frame range to be a little shorter. And now we can cache it out. Give it some name and click Save to Disk. I think that looks pretty cool. We have some interesting motion going on and some nice shapes. Let's improve it even further by giving it some thickness. So let's switch to perspective view. We subdivide the shapes by creating a divide node and uncheck the checked boxes and toggle breaker polygons, which allow us to have grid-like subdivisions on the shape. And we copy the X value to the Z value to make them uniform. Now let's quickly resolve the n-gons by dropping down another divide node, and this time leave all the parameters checked and change the maximum edge to 4. I want to push up the inner parts of our shape a little bit. So let's create a group which contains the boundary points because they need to be stiff. So create a group node, change the type to be points and uncheck the base group and check include by edge and unshared edges. Now we can create a transform node and select our group and then negate it by putting an exclamation mark in front of the group name. This still looks a bit jagged and we can easily improve that by subdividing it. Let me change the view. And then we can blur it out using the attribute blur node and increase the blurring iterations. To make this perfectly smooth, we can create a normal node and put the weight method to face area. disable the preview colors and create a color node. Change the color type to be ramp from attribute and the class to be primitive. Now we can feed in our rand attribute and create some nice colors. I'm going with some preset here, but you can and should of course put your favorite colors in there. So yeah, that's the main part of the tutorial. Now we have our Trippy solver and we created a nice bevel. Finally, I want to show you a little trick. We are going to add a kaleidoscope effect to make this even more trippy. I've already created an image network and loaded my rendering in there. Now create a crop node and crop out the most interesting part of your rendering. And then we can append a tile node and set the tiling to 2x2 and the tiling method to mirror. And now you get a very cheap kaleidoscope effect and you can adjust the crop to make it look really awesome. Yeah, this was my first Houdini tutorial. I hope you liked it and it wasn't too boring to you. If you have any suggestions or questions or you just like the video, then leave a comment below and see you next time. Bye.